जो करंट अभी अभी तुमने कैलकुलेट किया, जब करंट की वैल्यू आई नॉट पहुंची उसी समय किसी ने स्विच बंद कर दिया। तो स्टूडेंट्स प्लीज ट्राई टू अंडरस्टैंड दिस सिचुएशन नाउ। हेलो स्टूडेंट्स, आज हम एलसी सर्किट के ऊपर एक प्रॉब्लम करते हैं। आप में से जो लोग जेईई एडवांस 2023 को सिंसियरली अटेम्प्ट करने वाले हैं उनके लिए एक कॉन्सेप्चुअल प्रॉब्लम। ये एक सर्किट आपको दिख रहा है जिसमें दो कैपेसिटर हैं, दो इंडक्टर। कैपेसिटेंस की वैल्यू 2C और C है, इंडक्टेंस की वैल्यू L और 2L है। इस अपर कैपेसिटर पे, इस कैपेसिटर पे एक चार्ज है Q0। टाइम 0 पे सर्किट दिखाया गया है। इस समय इस कैपेसिटर पे चार्ज है Q0। ये कैपेसिटर खाली है, ब्लैंक है, इसमें कोई चार्ज नहीं है। टाइम 0 पे सर्किट की यही सिचुएशन है जो इस समय आपको बोर्ड पे दिख रही है। स्विच खुली हुई है, अभी खुली ही रहेगी, स्विच अभी खुली रहेगी। पहला क्वेश्चन ये पूछा गया है, फाइंड मैक्सिमम करंट थ्रू द इंडक्टर हैविंग इंडक्टेंस सेल। ये स्विच ऐसे ही खुला रहेगा, टाइम 0 पे ये सर्किट दिख रहा है। थोड़ी देर के बाद सर्किट में सिचुएशन बदलेगी, चार्जेस बदलेंगे। तो सब्सिक्वेंटली इस इंडक्टर के थ्रू किसी एक इंस्टेंट पे जब करंट मैक्सिमम होगा तो उस मैक्सिमम करंट की वैल्यू बतानी है। दूसरा क्वेश्चन है, ठीक से सुनिएगा दूसरे क्वेश्चन को। जिस समय इस सर्किट में इंडक्टर के थ्रू करंट मैक्सिमम हुआ, जिस समय इस सर्किट में इस इंडक्टर के थ्रू करंट पहली बार मैक्सिमम हुआ, उसी समय इस स्विच को बंद कर दिया गया। द स्विच इज क्लोज्ड एट द इंस्टेंट the current through the inductor becomes maximum for the first time. Take S is closed when current through the inductor is actually equal to I max. At that instant the switch is closed. So after the switch is closed, what will be maximum current through this inductor? Now the question is being asked, after the switch has been closed at this moment, subsequently what will be maximum current through this particular inductor? I dash max is the maximum current through this inductor after the switch has been closed. And remember, the switch was closed when the current through this inductor became maximum for the first time. I hope you have understood the question. Now you can pause the video, give it a try, and then you can refer to my solution. Okay, here I will try to solve the problem for you. I may not do all the calculations, right? I'll just tell you the basic thing that you need to do for solving this question. When the switch is open, and this capacitor starts to discharge, if I talk in terms of positive charge will start flowing like this. So this capacitor plate will start gaining some positive charge, and similarly negative charge will flow to this capacitor plate. So this one will become positive, this one will become negative. In a sense, this capacitor will get discharged and this one will get charged, right? At some instant the current here will be maximum. Current has only one value. Whether I say current through this inductor or this inductor, it has got same meaning right now, right? So the current flowing through this circuit will be changing with time. But when current is maximum in this circuit, it simply means there is no potential difference across the inductor. There is no induced EMF in the inductor, because when current is maximum, you all understand that di by dt is 0. Basically, current as well as charge on the capacitor oscillates sinusoidally in such LC circuits. So when the current becomes maximum, if the current is varying with time like this, when it is maximum, di by dt is certainly 0. At that instant, the inductor will have no EMF induced in it, because EMF induced in the inductor is given by L di by dt. So, when di by dt is 0, there is no EMF induced in the inductor. So, at the instant when the current is maximum, at the instant current is maximum, what are we going to see? We are going to see that there is no source of EMF in this circuit, and these are two capacitors, that's all. Please try to understand that these two capacitors will be actually in parallel, isn't it? Because this positive plate is connected to this positive plate and these two negative plates are connected together, isn't it? So, if I draw a circuit like this showing only the capacitors, the circuit is like this, it is like this. At the instant about which I am talking, there is no induced EMF in the inductor, and this capacitor, let us say has got X amount of charge on it, and at this instant this capacitor, rather say that this one is having charge X and this one is having charge Q0 minus X. Am I making sense? So, these are two capacitors in parallel, their negative plates are connected together here and their positive plates are connected together here. So, these two capacitors will have division of charge between them such that potential difference between both of them remains same. Potential difference between this and this plate will be same as potential difference between this and this plate. These all are same points in the circuit, they have got same potential. So, using this we can easily calculate the value of X, isn't it? If X is charge on this capacitor, X upon C, capacitance is C, it will be same as Q0 minus X by 2C. Therefore, 3X is equal to Q0, which means X is equal to Q0 by 3. So, we know the value of charge on this capacitor as well as value of charge on this capacitor. So, the instant about which we are talking right now, at that particular instant, please try to understand, at this very instant there is no di by dt, there is no di by dt, there is no EMF in the inductor, but it does not mean that there is no current, right? It never means that there is no current. There is current in the circuit, but at this instant there is no EMF, di by dt is 0. In fact, when di by dt is 0, current is maximum. For sake of simplicity of writing, let me write the maximum current as I0. You have just calculated that charge here will be 2 Q0 by 3, Q0 minus X, and here it will be Q0 by 3. So, at this instant charge is 2 Q0 by 3 and Q0 by 3, right. So, at this instant what is the value of current? That is what has been asked, and this can be answered using energy conservation, because there is no resistance in this particular circuit. So, there is no dissipation of any energy. So, whatever initial amount of energy was there in this capacitor, it will remain conserved in the circuit at any instant of time. So, the initially the capacitor was having an energy which was equal to half Q0 square by 2C. Only one capacitor was charged, and this will be same as the amount of energy that you see right now. Now, some part of the energy is there with the capacitor in the electric field between the plates, and some part of the energy is there with the inductor in form of magnetic field energy inside the coil. So, let us write the total energy right now. It is half L I0 square in this inductor, and this is half 2 L I0 square in this inductor. This is magnetic field energy, and these two capacitors are also having some energy right now. So, add those two energies, you will get half. This is 2 Q0 by 3, 2 Q0 by 3 is the charge divided by 2C, Q square by 2C, and this one is having energy, that is half Q0 square by 3 whole square divided by C. So, just by simplifying this expression, you can get the value of I0. Are you getting my point? When the current is maximum, there is no EMF. Using this fact, we were able to calculate the charge on these two capacitors, because at this instant potential difference here and potential difference here will be same. The two capacitors in a sense are in parallel. So using that, I was able to calculate how much charge is there on this capacitor and how much charge is there on this capacitor when there is no EMF in this circuit right now. So if I know the value of charges on the capacitor, I know the amount of energy stored here. So initially total energy given to the capacitor system is this much, and at this instant the energy in both the capacitors is this much only. This plus this is certainly less than this, you can calculate that. So where has that energy gone? It has gone into magnetic field energy, it is stored inside the inductor. So energy in these two inductors will be actually equal to this minus this, and this will give you the value of maximum current before the switch is closed. So you do the calculation yourself. Now when the switch is closed, the question says switch is closed at the instant when the current here is maximum I naught. जो करंट अभी अभी तुमने कैलकुलेट किया, जब करंट की वैल्यू आई नॉट पहुंची उसी समय किसी ने स्विच बंद कर दिया. तो स्टूडेंट्स प्लीज ट्राई टू अंडरस्टैंड दिस सिचुएशन नाउ. इफ द करंट इन दिस सर्किट इज आई नॉट and you are shorting this switch, what is going to happen? Now this inductance 2L and this capacitance C, they are connected to one another directly, that means they are in parallel, and this one and this one, they are in parallel, they are connected to one another directly. Now a separate LC oscillation will take place here and a separate LC oscillation will take place here. Now what is happening here has got no relation to what is happening here actually. Can you understand that? Now these are two independent circuits in a way, right? These are two independent circuits in a way. This capacitor, which is having a charge of 2 Q0 by C right now, was it 2 Q0 by C? 2 Q0 by 3, so sorry. When this capacitor is having a charge of 2 Q0 by 3, at this particular instant, this has got connected to an inductor, directly connected to an inductor, and at this very moment the current is I naught. Value of I naught is known to you, you have calculated it. Similarly here, this capacitor right now is having a charge of Q0 by 3 and the current here is I naught, the same current. Now here an LC oscillation will take place, here also an LC oscillation will take place. So the question asks, what will be value of maximum current through this inductor? Now again you have to use energy conservation. Now this particular loop which is independent of this loop, how much energy is it having? The total energy that it is having is half L I naught square plus this energy, which is half Q square, this Q square by 2C. This is the total energy that this loop is having. And when the current here becomes maximum, when the current here becomes maximum, you all know that the entire energy gets transferred to the inductor, magnetic field energy. So this will become half L I max square. This I max dash जो मैंने initially कहा था. After the switch has been closed, what will be maximum current through this inductor? So when the entire energy gets in form of magnetic field energy, at that instant the current will be maximum. So here the maximum value of current will be obtained by simplifying this. We know the I naught, we can calculate I max. Similarly here also you can calculate, if required you can calculate what is the maximum current through it, right? In this particular branch, the current will not be I naught, it will not be this, it will not be equal to, actually if I call this current as I1 and call this current as I2, then you can see that in this path actually current will be a sum of I1 and I2, taking care of plus minus sign of course, whether the direction is this way or this way, but this path you can just think of it like this, yaar, that there are two connections here. Current I1 is going like this and current I2 is going like this. These two are independent. It's fine thinking like this. So students, I hope that you have understood this concept. In past, in JEE Advanced or IIT JEE, many a times questions have been asked on LC circuit, and most of those questions could have been answered using the principle of energy conservation. The same thing that we have used to solve this problem. Thank you and goodbye.